going to be talking about dividing polynomials. So the first way we use the way we divide polynomials is we can use long division. This is very similar to long division with integers. So what we're going to do is we're going to write down x minus 5, and we're going to say divided by 3x squared minus 14x minus 5. Now we have to be very sure that both of our polynomials are in standard form and there's no gaps in between the standard form. Like there's 3x squared minus 14x minus 5. There's an x squared, there's an x, and there's a constant. All of those have to be there. If not, we have to use a placeholder. I'm going to show you that on the next one. So let's just do this first one here. Since we're dividing by a binomial, which is 2 terms, we're going to start above the second term, writing our answers down. So we're going to look at the first 2 terms of both polynomials, which is x and 3x squared. So what we're going to ask ourselves is, what do we multiply by x to get 3x squared? Well, we multiply that by 3x. So now what we're going to do is we're going to bring this down. We're going to say minus. We do 3x times x, which is 3x squared. And then 3x times negative 5, which is a negative 15x. And then we're going to subtract these. 3x squared minus 3x squared cancels out at 0. And then we have a negative 14x minus a negative 15x, which becomes a positive. So this is just going to be x, and then we bring down the negative 5. Let's make that blue. Then we're going to do this again. We're going to look at the first terms of both polynomials. X times 1 is x, so we're going to say plus 1. And so 1 times x is x, and 1 times negative 5 is a negative 5, and our remainder is 0. So our answer to this is 3x plus 1. All right, let's do our next one. Our next one, we're dividing by x squared plus 1. That is in standard form, but we're missing an x term. So what we're going to do is we're going to start with x squared, but we're going to say plus 0x for a placeholder plus 1. Then we go to the next one, and we have 7x cubed plus x squared plus x. But we don't have a constant, so we're just going to put plus zeros because we need a constant, a placeholder for the constant. Since we're dividing by a trinomial, which is 3 terms, we start above the third term. So we look at the first 2 terms, x squared multiplied to get, what do we multiply? X squared to get 7x cubed, and that's 7x. And we're going to multiply that out to each of those. So we get 7x cubed plus 0x squared, it's just a placeholder, and plus 7x. 7x cubed minus 7x cubed cancels out. X squared minus 0x squared is x squared. And x minus 7x is a negative 6x. We bring down that plus 0. X squared times 1 is x squared, so we do plus 1 right here. So we get x squared. 1 times 0x is plus 0x, just a placeholder. And 1 times 1 is 1. We subtract those, and we get a negative 6x minus 1. This is our remainder. And when we have a remainder, we write it in a special way. So first we take our answer, 7x plus 1, and then we add our remainder, which is a negative 6x minus 1, and we always put it over what we divided by, x squared plus 1. And that is how we write our answer for long division. Let's do another example of those. This time, we're multiplying by we're dividing by 2 trinomials. Make sure they're in standard form. So we have x squared minus 3x minus 2. That's fine. We don't need any placeholders. Next one is 4x to the 4th. But we don't have a cube, so we do plus 0x cubed plus 0x squared plus 5x minus 4. So we had to have a few placeholders for the cubed and the squared. Since we're dividing by a trinomial, we start on the third term. What do we multiply x squared to get 4x to the fourth? 4x squared. So we multiply that out, we get 4x to the fourth minus 12x cubed minus 8x squared. And that gives us 12x cubed plus 8x squared, and we bring down the 5x. What do we multiply x squared by to get 12x cubed? That's going to be 12x. So we get 12x cubed minus 36x squared minus 24x. And we get 44x squared plus 29x, and we bring down the negative 4. What do we multiply x by to get 44x squared? It's 44. So we have 44x squared minus 132x minus 88. And we get the remainder of 161x plus 84. So our final answer is 4x squared plus 12x plus 44 plus 161x plus 84 all over x squared minus 3x minus 2. And there's your final answer. So those are a few examples of long division. Now, there is a shortcut to long division if we're dividing by a binomial, and that's called synthetic division. It's a little math trick that we can do to quickly surpass the long division process, but we only can do this if we're dividing by a binomial. So what we're going to do is if we're dividing by x minus 2, we're going to change the sign and we're going to put a positive 2 down, and we're going to do this kind of upside down box. And then we're going to take the coefficients of each term and write them down. They have to be in standard form, and if you're missing a term, you do have to use a placeholder. But this one is in standard form. So we do 4, negative 13, and negative 5. Your first step to this is you just bring down the 4 down here. Now you're going to multiply the outside numbers. 2 times 4 is 8. And then you're going to add the inside numbers. Negative 13 plus 8 is a negative 5. Then we multiply the outside. 2 times negative 5 is a negative 10. We add the inside. Negative 5 plus negative 10 is a negative 15. And that's your remainder. The very last number is always your remainder. If you're starting off with a degree of 2, x squared, when you divide, your final answer will be an x. It goes down a degree. So these two numbers, 4 and negative 5, represent leading coefficients or coefficients. So this is going to be 4x minus 5, and a remainder, we do plus negative 15. And we always put it over what we've divided by, x minus 2. So it's a little trick that we can use if we're dividing by a binomial. So let's try that again. If we have x plus 3, we make it a negative 3. Make that in blue, negative 3. Put the upside down box. And we're starting with a cubed, we put 1, but we don't have a squared, so we put 0 for the squared, then negative 4, then 6. So make sure we have a placeholder for those any missing terms. We bring down the 1, and we multiply the 3 and the negative 3 and the 1. So we get negative 3, and negative 3 plus 0 is a negative 3. Negative 3 times negative 3 is 9. Negative 4 plus 9 is 5. 5 times negative 3 is a negative 15, and 6 plus negative 15 is a negative 9. That is your remainder. Since we started off with a cubed, when we divide, that first term is going to be a squared. So this is going to be x squared minus 3x plus 5 plus negative 9 over x plus 3. And there's your answer. I have two more examples of synthetic division. We are dividing by an x minus 1, so we're going to put a 1 out in front and do our upside down box. We have a cubed is squared, but we don't have an x term, so we have to put a 0 for there. So let's do 3, negative 5, 0 for the x term, and then negative 2 is our constant. Bring down the 3. 3 times 1 is 3. Negative 5 plus 3 is a negative 2. Negative 2 times 1 is a negative 2. 0 plus negative 2 is a negative 2. Negative 2 times 1 is a negative 2. And a negative 2 and a negative 2 is a negative 4. Since we started with cubed, our divided is going to be squared. So our final answer is going to be 3x squared minus 2x minus 2 plus negative 4 over x minus 1. Our next one, we're dividing by a positive 5, so we're going to make that a negative 5. Draw upside down box. We have x to the 4th, which our leading coefficient is 1. 4x cubed, we don't have an x squared, so we put a 0 there. Then we have 16 and then negative 35. So we bring down the 1. 1 times negative 5 is a negative 5. 4 minus 5 is a negative 1. Negative 1 and negative 5 is a 5. 0 plus 5 is 5. 5 times negative 5 is a negative 25. 16 minus 25 is a negative 9. Negative 9 times a negative 5 is a positive 45. So our remainder is 10. So our answer for this one, since we started to x to the 4th, is going to be a cubed. It's going to be x cubed minus x squared plus 5x minus 9 plus 10 over x plus 5. And there is our final answer for that synthetic division problem. I have two more examples for you, and this is a little different. We can actually evaluate a function using synthetic division. So for number 1, if we didn't use synthetic division, if we were to evaluate this function, we would plug in 3 for all the x's and calculate that and simplify, and we would get a certain number. Well, what we can do is the same method, we can do a different method, and we can use synthetic division, and this is the remainder theorem. If we plug in 3 to synthetic division, whatever the remainder is your answer. So if x is 3, we write down 3. Standard form still applies, so we have to do 3, 2, and negative 20. So let's do our synthetic division, bring down the 3. That's 9, that's 11, and that's 33. So our remainder is 13. So if we were to evaluate the f of 3 and put it into our calculators, we would get the answer 13. But we can also use synthetic division, and our remainder gives us our answer. So let me show you how to evaluate using synthetic division for number 2. X is 10, so we put down a 10. We have x cubed, which is 1. We don't have an x squared, so we put a 0. Minus 9, minus 7. We bring down the 1. 10 times 1 is 10. 0 plus 10 is 10. 10 times 10 is 100. Negative 9 plus 100 is 91. 91 times 10 is 910. Negative 7 plus 910 is 903. It's a very quick way, if you don't have a calculator to evaluate this, a very quick way to plug in and evaluate. So the f of 10 is going to be 903. And there it is for synthetic division.